Alright, next we're going to be looking at slope, and also we're going to be looking at the slope of parallel and also perpendicular lines. So more on that to follow in a couple minutes here. So let's just go to the basic definition here of what is slope. Slope is defined as the vertical change divided by the horizontal change. And we abbreviate that in mathematics with this little symbol over here. It looks like a triangle, but it's actually called delta. So we say this is delta y divided by delta x. It just means the change. Delta means change in Greek. And so if we were over here looking at a couple of points, maybe this is point A for instance, and this is point B, if we wanted to find the slope between those 2 points, it's basically what we've used before in algebra. We look at it as a slope triangle here, and this is the change in y, it's the vertical change, and this is the change in x. So we would want to calculate that. So here's a couple points here. I've got one point is 5 comma 28 and another point is negative 5 comma 40, and we're going to go and find the slope between those 2 points here. Now if we were just drawing a sketch, and I'm just going to go ahead and draw a sketch right over here, 5 comma 28 would be somewhere, say over here, so I'm going to write 5 comma 28, and negative 5 comma 40, that would be negative 5 in this direction, and comma 40 might be up over here somewhere. And what we would do is we would go ahead and we could connect those, and then we would want to know how much vertically it changes and also how much horizontally it changes here. And you'll notice here that this line is actually going downhill, so we know our slope is going to be negative here. Now I picked these 2 points on purpose because they're not very convenient for actually taking graph paper and graphing these points out where you could actually make this slope triangle here. So we're going to just kind of logic this out instead here. So I'm going to write over here slope. So slope will equal the change in y divided by the change in x. That's the definition up here for slope. So let's look at the y's here. One y is 28 and the other y is 40. So one way you can look at it is to get from 28 to 40, what would you have to do? So in other words, 28 becomes 40. If you're standing at 28, how would you get to 40? Well, you'd have to go up 12. So we'd be going up 12. Likewise, if we were looking here at the x's, here's one x, here's the other x. To get from 5 to negative 5, what would you have to do? You'd have to go down 10. And so in this case here, our slope would be 12 over negative 10, and we can go ahead and reduce that, so that will become negative, and when we divide these both by 2, that'll become a 6, and the bottom will become a 5. So that ends up being our slope. Okay? You may have also learned this in your algebra class, that slope is defined as the second y minus the first y divided by the second x minus the first x. And so if you want to use the formula, that's fine. And so in this case here, I'm going to go back to these points here, and this would be our first x, and this would be our first y, and this would be our second x, and this would be our second y. So according to the formula, what we would do is we would take the second y, which is 40, and subtract 28. So we would take 40 minus 28, and the second x is negative 5, and the first x is 5, so we could say minus 5, so we'd wind up with 12 over negative 10, and that's the same as what we see here, just the negatives in a different spot here, so it ends up getting the exact same answer. So you can either do it this more informal way, or you can do it with the formula. It's up to you. Now the final ideas here would be in terms of these two words here, parallel lines and perpendicular lines. So if we were to talk about them, if you have 2 lines that are parallel, they never intersect. So if you ever hear about parallel lines, you'll know not only do they never intersect, but they have the exact same slope. So in line 1, if the slope was 4, in line 2, the other slope would be 4 as well here. Now perpendicular lines, they will cross, and they intersect at a 90-degree angle here. So for instance, if I had one line like this, the other line might be like that, and they would cross and form a 90-degree angle. And you'll notice here in this case that one is going uphill and one is going downhill. So you'll always notice that the slopes will be opposites, which means one will be positive, one will be negative. Also, they're reciprocals. So if you know the slope of one, you can flip to be the other. So let's say I had line 1 and I also had line 2 over here. And I told you that the slope on this line was 3 over 2. The other one would be the opposite in terms of sign, so it'll be negative, and then reciprocal means you just go ahead and flip this, so it'll be negative 2/3. If line 1 was negative 4/5, that means line 2 would be positive 5/4. And finally, let's say this was negative 6. Well, that would be negative 6 over 1, so this would be positive 1 over 6. So that would be perpendicular lines. You would always know the slopes are opposite reciprocals.